So, oh, that's silly to start. If you don't want to write this down, you don't have to, because it's just a review of all the notes that you already have, but you may want to anyway. The number one thing that I feel is most important to this entire unit is to be aware of the quadratic equation and all the things it will do for you. So, first thing I would like to remind you of is the quadratic formula. Do you have to memorize it? No, of course not. You just have to know how it works. And of course, that is ax squared plus bx plus c. There's them. There are the a, b's, and c's, as of course you remember. The first thing that will give you are the roots of an equation, which are also called the zeros. That is the first thing it will give you. The second thing it will give you, the discriminant. Will tell you the shape the discriminant can be is b squared minus 4ac. If it is greater than 0, 2 roots. If it equals 0, 1 root. If it is less than 0, no roots. And the last thing it'll tell you is vertex x is negative b over 2a. All that comes out of the quadratic formula. When does the quadratic formula work? Every single time you have a quadratic equation, the quadratic formula will work. Always. You can always use it. Sometimes it's a pain in the ass, and sometimes when that happens, you should use one of the other methods. But if you can work with the quadratic equation, you can do everything in this entire unit. Okay? That's all you need. So that's why it's first. Any questions about it? No? All right. I would argue the second most important thing in this unit is vertex form, which is, of course, y equals ax. Do you guys like the p or the q or the p and the q or the h and the k here? I don't really care. Go with h and k so we don't mix it up when we're doing factored form. Yeah? Okay. Minus h squared plus k. H, k equals the vertex. What do you have to remember about h? Opposite. Right? That's I believe, personally, my own personal opinion, that is the easiest method to work with because it is the easiest method to graph from. Again, personally. Because it tells you everything you need to know. 3 ways to get there. One, you can complete the square. Complete the square on ax squared plus bx plus c equals y. Complete the square on that, you get to here. Right? Everybody's good with that? Does anybody need more than that? Okay. The other way you could do it is the roots give the vertex. And once you have the vertex, you can plug it in for h and k. How do the roots give you the vertex? Root 1 plus root 2 divided by 2. And the third thing you can do, of course, is the x and then sub it back in. Any questions about that? No? Excellent. And the third thing, I want that to be black. And the third thing is factored form. Which is, let's make that orange. Not plus, you idiot. P and Q are, I don't want to write it with a comma because that looks like it's coordinates. P and Q are the roots. And remember, they are opposite. What's the same in all three? Oh, sorry. When you've got the roots, roots give the axis of symmetry. Forgot the R. And that's the root 1 plus root 2 divided by 2, which is also your Vx. What's the same in all of them? A. A is common. What do we know about A? Positive A means what? That. Negative A means what? That. If I move that way x, how far up do I go with a positive A? A times x squared. If it's negative A and I move that way for x, how far down? Negative A times x squared. Yes? How do I find A? Find A by isolating. How do you isolate A? Use any point as x and y. What are some points you could put in? When I say any point, you could put in one of the roots. You could put in the y-intercept. You could put in any point from the graph. The other thing you can do to find A is you can count on the graph. If you're at 2, 7 as a vertex, and the next point you see on the graph is 6, negative 9, what's the A? Two, 7, and the next point you see on the graph is 6, negative 9. What's the A? How far did you go from 2 to get out to 6? 4. How far did you go down from 7 to negative 9? 16. So since you went downwards, is your A positive or negative? Negative. And you went over 4 and down 16. Was there a stretch? No. So what's A? Negative 1. There you go. All right. Everything's in one place. If you understand that entire page, you are all set to get an A on your test tomorrow. Is your test open book tomorrow? Mm-hmm. Can you use your graphing calculator? Uh-huh. What? No. So I'm going to wait and see what tomorrow's test does. If everybody bombs it, obviously I need to spend longer with this, don't I? Because if you're bombing the open book one, what's going to happen when I actually ask you to do something? All right. Now, does anybody wish to see a bit of work on the next blank page on use of your graphing calculator? I don't really care because you don't need it, but I'm willing to quickly review it. Yeah? All right, if you're going to use your graphing calculator has two jobs. One, it can do the work for you. if you know how to use it. 2, you can use it to check your work if you show me all your work, right? It's an easy way to check. So if you're going to use your graphing calculator, you have to remember a couple of things. The most important button is the y equals button. It is the top left corner. Very top left corner button. That will take you to the equation screen. On the equation screen, you enter your equation. But there's a rule to that. Your equation must be in this form. Must be y equals. So let me give you an example. Let's say I tell you that you have a quadratic relation whereby you're jumping off a cliff. And that cliff is 50 meters high. Right? So 50 equals whatever your whatever the equation is that is going to model you falling. Everybody understand? I started at 50 when I had 0 time, right? Because I'm jumping off the cliff, so I'm already up off the ground. Everybody cool with that? Can I enter that into my calculator? No. This has to move. So it would actually go into my calculator equals negative 4.9 x squared minus 24x minus 33. Because I got to move that to get to this form. Everybody cool? Right? Once you enter it, you hit the graph button, and then you're in trouble. Maybe. Because the graph button will give you one of two things. One, it will give you a graph. If it gives you a graph, you can go ahead and use the second calc button. And what does second calc find you? Everything else. Values, which are x values. Zeros, which are roots. Vertex, which is either a min or a max. And you can use it to find intersections. What if there is no graph? Then you've got to check zoom or window size. Yeah? All of these things, I lie, value isn't going to do that. Zeros, root, and intersection, it's going to do the left boundary, right boundary, and guess. Yeah? Everybody good? Okay. Let us then, cabbages, because that is all recorded. Let us go back to the beginning of our review and mark it. Get that ready to go. Maybe you don't. I have said I want you to complete the square here. Can I prove it if you don't? On a multiple choice test, if I said complete the square to tell me this, could I prove it? No. Can I prove it on an open-ended test? Yeah, because you'd have to show me what you were doing. That's why this is open-ended. I wanted to see this done by completing the square. If you didn't do it by completing the square, but you got the right answers, you may have 1, which is because finding the right answer is half of what I wanted you to do. It's out of 2 total if you did it right. Now, a lot of kids in my other class had a lot of problem with completing the square. I don't really know why. the first thing that you should do, and it is in every example I've ever showed you, is to get rid of that 18 because it is in the way. Now, I shouldn't say that. If you are not sure about completing the square and you Google it, not very many people will do this step and move that 18 out of the way. I don't know why they don't do that. What most Google, if you try to learn this yourself, they will do this first step here. They'll move out the negative, but then they'll leave this negative 18 here, and they'll write another number there, the square. I don't like doing that, but if you like it, you've Googled it and that works for you, are you allowed? Of course. I move that 18 over here, so I get y plus 18. Then I add my 25, half of 10 squared. But since I have a negative out front, I'm actually subtracting 25. Then I do my work. Okay? Any questions with completing the square? Get rid of C, do the work, bring C back. All right? That's how I like to do complete the square. Graph each equation. Easy to graph because it's in I'm doing slope intercept with my grade 10s right now. Easy to graph because it's in vertex form. Vertex is positive 4, negative 3. There it is right there. It's got no stretch, but it's negative, so I go over 1, down 1, over 2, down 4. Also in vertex form, except there's no Q, so it's plus 0. So I'm at 0. It's a positive A, but no stretch, so over 1, up 1, over 2, up 4. Any questions there? Those are worth 1 each because they're already in vertex form. You only had to know one thing to graph it. Any questions yet? Spectacular. Identify the max and the min of each and then sketch the graph. Well, this is in vertex form. Or not vertex form, sorry. Factored form, isn't it? So my roots are positive 3 and 0. Got them. Halfway between positive 3 and 0 is 1.5. That's my vertex x. Once I put 1.5 in for x, I get my y value, which is negative 4.5. So my minimum is at 1.5, and its value is negative 4.5. I need to see the graph. That's not supposed to do that. It's supposed to be a highlighter. I need to see the graph and some statement like that to get your whole 2 marks. And then the same thing over here. Making that whole page out of 10. Does anybody have any questions on that page right now? Let me ask you this. If you wanted to, could you expand this, complete the square, and find the vertex that way? Really? Did it work? No problem then. Feel free to keep doing it. Expand or die. Yes. If it ain't broke, don't fix it. Good call, Ashton. All right. If nobody has anything to say about that, we'll move it along. I want the vertex form of the parabola. There it is. This already had the vertex, and it had the y-intercept. Once I have the y-intercept, of course, that's an x and a y value, isn't it? So all I do is put those values in here and I solve to get negative 3a. Negative 3 equals a, so there is the final answer. Once again, are we doing any grade 11 work here? Really? Not really, because I've already given you the vertex, so the only thing you're doing is solving for a, and that's algebra. And it doesn't matter if it's a line, a curve, or what. It's still made of x's and y's. Any problems? Going once, going twice, going thrice. There's the next one. Same thing. If it opens up or down, that must mean I have two kinds of a's, either positive or negative. I got the vertex, and I've got my y-intercept. So I just solve it exactly the same way, except you must have the plus or minus, because it could go both ways. Same thing for number 9. There it is. Any questions doing it algebraically? I see a lot of people writing a lot of work down right now. That's cool. I didn't do a homework check because, kind of like it when everybody says they got 39 out of 39 and then get nothing on the tests. Kind of makes me, laugh. Of course, these were already given to you, so you had to work backwards. You had the vertex. Once you have the vertex, you could simply count to get a. This one looks tricky because, of course, it's divided into 0.5s, but it's still just counting. That makes that page out of 10. When I say non-calculator, what do I really mean? No graphing calculator. Because I know a great many of you have a lot of trouble with doing 2 minus 5 squared. With whom? In a perfect world, you should be able to do this without a calculator at all. But I have many, many times asked my grade 11 students, what is 3 squared? To hear silence. I did it in my head. 4 times 3 is 12. 12 times 60 is 720. 12 times 5 is 60. 720 and 60 is 780. 900 minus 780 is 120. Yes, you can. You just don't. There's a difference. There's can and will and can't and won't. I can't speak Sanskrit. I won't speak French. Do you hear the difference? Okay. I can read all the lyrics to Bohemian Rhapsody. I won't sing it because I have a range of exactly 1/8 of an octave. One note. Right? I do not have Freddie Mercury's 5-octave range. I lie. He's got a 4-octave range. Well, he's got a no-octave range now because he's been dead since 1990. But when he was alive, he had a 4-octave range. Beyonce has a 5-octave range because she is awesome. Except she married Jay-Z, but what are you going to do? Maybe he's a great guy. I don't know. He is a little weird. But so's she, right? I mean, all famous people are weird. They have to be, right? How could you not be weird when you have a bunch of people following you around doing exactly what you ask? I'm thirsty. I need a Coke. And a Coke appears in your hand, right? When you're that famous, you're like a magician. Somebody whose name you never know brings you a Coke whenever you ask. How could you not get weird? When I want a Coke, I sit in my house, I'm sitting on the couch. Man, I'm thirsty. I'd like a Coke. You know what my family does? Get off your ass and get it yourself. Right? So, anyways, non-calculator technically means non-graphing calculator. Now, I have talked long enough that you have been able to copy all this down and pretend like it is your work. Is there anybody that needs any of that explained? It's out of 7. Everything is worth 1. Now, the only thing I would suggest is this. You could go further, yes? You could simplify this to break it all down, get rid of the, simplify the fraction. I don't really care. If you get to there, you get your full marks. Everybody okay? Nobody needs any explanation? Spectacular. Moving on. Oh, there it is. I'm getting you to do it again, but I only want 3 things out of this one. Any questions? No? Lovely. So, notice here, please, I have done all 3 methods. I do not care which one you used to put the equation into vertex form. Don't care at all. You use the one you like. Now, 1, 2, 3, 4, 5, 6. I gave you 2 marks for doing A. One, two, three. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. And there's the rest of it. And it has all been recorded. Are we all good? Yeah? Okay. Now, something that I have found in my many years of teaching this course is that you kids are sometimes not so hot at using quadratics. What do you mean by using quadratics, Mr. Myers? I'm talking about word problems. Don't stick your pencil into your eye, buddy. You'll be fine. So, part of the problem you're not so hot at word problems is... What? You don't know when you have the right answer is the biggest problem. But of course, if you can get an equation, you always know when you have the right answer because you have the right answer when it is isolated, yes? That's how math works. So I'm going to give you an example and we'll see how we do with it, okay? Do you have to write this down? No. But I would recommend paying attention because it's kind of how it's helpful. So I was doing a little bit of looking around and I found a couple of questions that I liked. This is one that I think is particularly timely, and I'm going to use this one right now because it uses decimals. Because in the real world, there's a whole lot of decimals, yeah? So I found a model, a mathematical model, climate scientists use to measure carbon in the air. So the model is this. A, that's your carbon in the air, all right, equals 0.3 t squared plus 0.1 t plus 4.2. T equals time in years. A equals carbon levels. Now, because I have T and I have an A, this model will tell me two pieces of information, won't it? If I tell you that I'm going to measure the carbon level in 10 years, can you tell me what it will be? Yes, what would you do to tell me? You could graph it, but I'm telling you it is in 10 years. Plug 10 in for T. Okay. Now I am telling you the carbon level is 300. That's when we're in big trouble. How could you use this to tell me when that would happen? 300 for A, and then do what? Isolate for T. Now, since T is squared, there's going to be two values, aren't there? One will probably be what? Negative, and one will be positive. Will the negative one help? It's not going to happen unless we've already passed it, right? In which case, we would know that we were screwed. Everybody understand? That's all you do with these. You just read the question, find out what you're being asked. Are you being asked a time or an independent variable? If you're being asked for that, you must solve for x. Where on a parabola do you find the answers? Where on that parabola would you say are the answers? Pardon me? Roots might be it, or the y-intercept, right? Actually, you know what I'm going to do? I just want to do something a little different here. I want to draw it this way, because I don't want the vertex to be on the y-intercept. That's an important point. That's an important point. That's an important point. That's an important point, right? Green, yellow, blue, green. Which color is an x value only? Green. So if you were looking for an independent variable, where do the answers live? The roots. Easy peasy, right? Right? Okay. So if you are ever looking for an independent variable, you're finding the roots. Yeah? If you're ever looking for a dependent variable, you're going to have an independent variable to plug in. Everybody okay with that? Yeah? Okay. So I'm going to tell you this. I'm going to say we need to, when carbon levels in the atmosphere reach a level of 20, we need to change our emissions. So how would we do that question? So I am telling you right now, carbon levels greater than 20 are bad. How long do we have before we can deal with it? What are we going to do with that question? Pardon me? We have to find out when that's going to happen, yes? So what are we going to do with it? Is that an A or a T? So 20 equals 0.3 t squared plus 0.1 t plus 4.2. Could we do that right now with our regular calculators? Yes. Since we seek a t, what are we looking for? We have to isolate it, which means we are looking for roots, yes? So what will you do with that so we can isolate t? We're going to move it over here. And now we've got 0 equals 0.3 t squared plus 0.1 t what? You can use your calculator for that tricky addition and subtraction, ladies and gentlemen. What is it going to be? Negative 15.8. Now, that's barfy. Would we complete the square? No. Would we factor it? No. What would we do? We would use A, B, and C and run it through the quadratic equation. Now, since this is a real life question, would I leave it in barfy radical form? No. So I would run this through, yes? And it would be hideous, yeah? But we would get the right answer, right? Could I run it through my graphing calculator if it was not a math question? Like if I was in the real world and I was doing work with this, would your supervisor be leaning over your shoulder saying, no graphing calculator? No. You would punch that into your graphing calculator and find the roots. Right? Everybody cool? Okay, let's try another one. Huh? Well, you could, but that is a model. It's predicting, right? Yes. It could. It won't. All right, let's remember that 2.5 billion people on the planet live in countries that haven't completely gone through the entirety of the Industrial Revolution. So all that pollution that a measly little bit of England and Europe going through the Industrial Revolution that has ruined the planet still has to happen for 2.5 billion other people. It's not getting any better. All right. Let's do another one. Let's do a real life question. Another real life type of question. Let's see. If I own a store, I sell stuff, yes? Everybody with me? You've all been to stores. Stores sell stuff, don't they? How do stores get the stuff? What do I have to do if I own my store? I got to go buy it from somebody else, yes? How do I make money? I sell it to you for more than I paid for it, yes? Everybody understands? It's making money. Easy peasy lemon squeezy, right? You can't go and buy that stuff from the wholesaler. You can't go to a factory and say, can I please get one jacket? No, because they're making millions of jackets, yes? Okay. All right. What happens at the beginning of wintertime? No, I don't like winter. Beginning of summertime, I own a surf shop. I sell surfboards and surfing equipment. We live in this cold part of the world. I need to sell wetsuits, yes? Beginning of summer. Not beginning of summer, spring. What is the demand for wetsuits? Would it be high or low? High, because people are going to start going surfing, yes? So, should I, in my store, have a good selection of wetsuits? Yes. And they're going to have a price. Everyone agree? You are going to buy them. Yes? Should I order more, less, or should I be shooting for the exact right amount that I need? Exact right amount. But I cannot tell the future, can I? So I order in a bunch of wetsuits. We have a crappy spring. It's rainy and gross. What happens? Nobody buys my wetsuits because they're not thinking about going out surfing. So what does that mean at the end of summer? I'm going to have a surplus of wetsuits, so I got to blow them out, yeah? And that is how it always works, yes? When is the best time to buy your ski equipment? Right when ski season ends. In the summertime. Everybody cool? All right. So I do this for a few years, and I notice that when I dock price, when I lower the price, more people buy wetsuits. Everybody happy with that? Makes sense, right? You put something on sale, people buy it. Can I continue to drop the price? If every time I drop the price, a few more people buy my wetsuits, can I continue to drop the price? Why not? Why must I stop? At some point, I lose money.
You're going to lose more money if you sell them.
You could make that argument. I agree with you, Ashton.
You're going to lose money no matter what if you sell them for less than you paid
At some point you have to decide, are you going to cut your losses? Yes? But you don't know when you're at that point till you're at that point, right? Do we agree? So you predict. That's how stores work. That's how everybody works, right? If you have a job, you are predicting how much money you need to spend from your income in a month, yes? But let's say you have a car and you run over a nail and you get a blowout on your tire and you have to buy a new tire. And you have not predicted for that. You're screwed, yes? All right, so let's run this example. Let's see what happens. I sell wetsuits. Again, you don't need to write it down. I sell wetsuits for $250 a suit. Everybody okay with that? I sold 90. No, let's make it 100 so it works nicely. I sold 100 suits last spring. How much money did I make? What math do I do? I do multiplying. So what would I multiply? My money equals what? 250 times 100. Does everyone agree? Right, yeah. But we're not, let's keep it simple, right? I want to show you how quadratics could help me. Everybody cool? This is last spring. Everybody agree? So that was March. This is now November, right? I got some wetsuits left in my shop. Everybody okay with that? What am I going to do with them? Because it's November, right? What do I need to do now? I got to sell them. Anybody going to buy them? So what do? I put them on sale. Everybody cool with that? So here it is. It's November. I docked the price $15. Everybody agree? Okay. Where's that 15 going to go? With the 250 in yellow or with the 100 in blue? The yellow. So my new price is 250 minus 15. Everyone agree? And I sold 5 more wetsuits than I normally would sell in a month. So where does that go? 100 plus 5. Now, I need to predict next spring. Can I see the future? No. But I have some data now, don't I? A lowering the price of $15 sells 5 more wetsuits. What would happen if I lowered the price by $30? 40? More. It would go up, yes? So, if I lowered the price by 15 once, I would sell 5 more suits, yes? What if I lowered the price by 15 twice? What would happen? 100 plus 5 twice, yes? What if I lowered the price by X? 100 plus 5x. What do I have right there? A quadratic equation. It would graph this way, wouldn't it? Why? Well, expand or die. If I expand or die, I end up with negative 15 times 5x, right? Which would be negative 75x squared, right? And the x squared term is your a term, yes? So I've got this, right? So what does that give me right there? It's a vertex, which is a maximum here, isn't it? Don't I want the maximum amount of money? Which will give me an x value, won't it? Which would be how many price reductions I could make to maximize my profits. You guys are intelligent young people. You've been to hockey games, you've been to concerts, you've been to basketball games, you've been to places where they sell tickets, yes? And sometimes you see empty seats, don't you? right? You paid $85 a ticket to see, name some band that you guys would go pay money to see. Wait, you're kids. You steal all your music. So let's pretend it was 30 years ago, like when I was your age, and I actually have to pay to see a band live. No YouTube, no nothing. I got to pay to see them. If it's an outdoor show, you jump over the fence, and then the rent-a-cop security guards get a hold of you and beat the piss out of you. When I was your age. Now they say, can you please leave? Because even the security guards are soft. But now, seriously, you paid whatever to see a show. Concerts are expensive. My first concert, who wants to guess what it cost? Just guess. $21.75 to see a concert at the Pacific Coliseum in the lower seats.
Those are like hundreds.
I know. Anyways, the group was In Excess. None of you have ever heard of them, so it doesn't matter. But now it's way more, yes? I'm taking my family to see Sum 41 and The Offspring here in Abbotsford. $500 to take 5 of us. I know, it's crazy. It's ludicrous. It's $100 a seat. I'm not even looking on Groupon because I know that Abbotsford, when they don't sell out their shows, they put the tickets on Groupon. You get them for nothing, so I'm not even looking. But that's what I'm trying to get at. There are empty seats, yes? If they lowered the prices, could they fill those seats? Yes. And this is what Ashton was just talking about. You're better to lose less money. So at a certain point, they decide there's not enough people buying tickets, so we're going to put them on Groupon for nothing. Because they already have to pay to rent the arena. You could hold them for next year, but have you not met you people? Is your iPhone 5 still capable of going on the internet? Is your iPhone 5 still capable of iMessage? Does your iPhone 5 take pictures? Does it go on Insta? Why do you need an iPhone 11? Do people buy them? Yeah. Because nobody wants last year's wetsuit. Nobody wants... Why do you think leasing cars is way... Most people get their cars nowadays? Because you get a new one every 3 years. And what does the car company do with that lease return you sent back? Sell it for way more than it's worth. Leasing is the best thing you do for the car companies because they make their money twice from you. Yeah, little bit. But what are you going to do? Keeps the world going. Got to keep that economy moving. We should. But that would require us to actually use something until it is no longer useful. And that would require, not caring about things like fashion. Which, just, let's be honest, it's not going to happen. Because we have everything we need so we can care about fashion. That's why we in North Americans sell a pickup truck for $100,000. Go to India, for example, and say, hey, would you buy this vehicle for $100,000? And what will they say? No. Why would I ever do that? No, it's not because you have to convert it to rupees. That's like saying in Vancouver, I will buy this 600 square foot bachelor apartment for $1 million. 600 square feet is smaller than this room for $1 million. And there is a lineup of people willing to do that. Now, move to Flin Flon, Manitoba. Exactly. And see how far $1 million gets you. I'd like to buy your entire city, please. Sold! Here you go. Why? Because we have everything we need, so we seek nice stuff.
And then I'll just buy a whole bunch of land in an area in the middle of nowhere, and then just start developing it.
If you build it, they will come. You've seen Field of Dreams a few too many times. There's ghosts in the corn. You plow under your corn and make a baseball diamond, and people will show up. Have you seen that movie?
No, I haven't. So you don't just all stop working and start working for each other.
Communist. Pinko. All right. Okay, so we're done. This unit. Is everybody cool? We are done. You are writing 2 tests on it. Are the concepts showing up again? Yes. In the very next unit. No. Everybody cool? All right, now listen. We're going to do something a little weird here. Please turn in your books to page 126. But of course, no, you already know how to do this because we've already talked about it a little bit this year. All right? So let us start, and again, we have to start simply, not quite that far back, but we have to start simply. If I gave you this, what would you do? You would all yell 7. But what would you do, really? You would do x equals 10 minus 3, and x would equal 7. Yes? Right? Okay. What if I gave you this? Now what would you do? 2x equals 15 minus 5. X equals 15 minus 5 divided by 2. And x would equal 5. Excellent. What if I gave you this? Expand or die! Of course, you don't need to expand because it's 2 and 18, but x plus 3 equals 18 divided by 2. X equals 18 divided by 2 minus 3. X equals 6. Right? You can all do that in your sleep, yeah? What do you notice about all of those answers? Okay. Keep talking. They're all positive. Okay, keep talking. Pardon me? Whole numbers? Yeah. Greater than 0? How many values satisfy that yellow equation? 1. How many values satisfy that green equation? How many values satisfy that pink equation? 1. When you are doing equations, how many answers are there? 1. What if it's a quadratic equation? 2. But there's answers. Agreed? Okay. If I change this sign, now how many answers are there? Infinite answers. Because, of course, that says x is less than 7. Agreed? In this one, 0. Oh, there goes my pen. I should have known. What time is it? 10:35. There's going to be 2 videos today.